So this is our agenda today. All right, so we're gonna solve this problem, okay, guys, which is this one, okay, it's this one, pentagram, okay. So this is a this is a interview question, okay. So and then you may have seen this one. Basically, the idea is there's a phrase, and then basically the problem is to check whether the phrase has the entire script of the language. Okay, so so this check is it's really common like an interview question for checking few things. Okay, so all right. So what is the um, inputs here? What are the inputs? Yeah, the phrase and the alphabet, both, right? So basically, the thing is, usually this is this question is asked for only English, but you can, if you want, you can further generalize the solution for any language that has an alphabet, because not all languages has a defined alphabets, right? So I'd say like here you will have problems. Okay, so I think Mandarin you have a challenge to find what's the proper alphabet, right? So, but other languages like Hindu or my own language like Sinhalese, we have a correctly defined character set, which the set is in Unicode. So if you have that, and then usually there are online resources that kind of group that Unicode set of characters into that, right? Then you basically use that. Okay. So yeah. So the thing is, right, so there is a phrase, and you basically going to check whether all the characters in that particular alphabets it's in the phrase. If it is there, then what you should return? True, right? Otherwise false. So this is a true false returning function. Okay. So the input and output. So the inputs are the phrase and the alphabet, right? So alphabet, I think it should be right here. Where did I write it actually? And the alphabet, the output basically true or false. Okay. All right. So let's do our understanding over here, guys, in the main program. Okay. So, well, the problem says about an alphabet, right, and a phrase. So this is like looks like a string processing problem, right? So it's basically it's natural for us to explore string in Python. Okay, and that's what I did over here, guys. Okay, so you can start with this one, and then if this is an interview, you can ask from the interviewer that can you do this, like can I explore strings in Python in Google, right? So usually they don't like googling the solution, obviously, right? But you know, these are interview questions, they are really popular posts in the internet, so there are a lot of you can find in the internet. So do not search for the solution, but the other auxiliary knowledge you need, you can Google that in an interview. Okay, so in here we are googling Python string. So this is how you should Google. Just minimize it to like, you know, 2 or 3 keywords, and then that will lead to the most trusted documentation, which is the documentation of the language originator. In here it's Python. Okay, so we're going to go over here, and you can see that this is actually a string module, right? So basically it goes to string module. See that string dot? right? The other one, if you click right, I mean, if you click here and then go to this website, this is string class. See that, that's why this str type. Okay, so these are two different things, right? So string module has bunch of commonly used literals, and you can see over here ASCII letters, ASCII lowercase, and then this again in English alphabet, right, and uppercase, and you can see that it actually gives you this literal if you access this. Okay, so the reason why they made this enable is, and you might often need these things for text processing, right? So then basically these Python designers thought, oh, why not actually pre-build them and then make it available for users? So that's what they thought. So they actually created a bunch of literals for digits and then all of those like punctuation and all sort of things, right, into this module, and then included those. Okay. So, and you can see they are not functions, right? They are actually constants. So see here, right? They are not functions, they are constants. So they are pretty much literal values of strings in coming from a module. Okay. So we're gonna basically import string module over here. Okay, and we're gonna do few things. We're gonna test few things out over here, right? So let's first print the content of that module, which is the lowercase one, right? So string dot, right? I think it's this one, ASCII lowercase. Okay, and it's actually printed the alphabet, right? So, and you can see that, you know, if it's an alphabet, we know that all letters are unique and distinct, right? And well, there's no repetition, there's no two a's here, right? Just one a, right? So what do we call such a group of thing normally? You can try to recall high school math class as well, maybe. What is it? No, we there's a specific name we use for, okay, so the items, we know that's a group, it's ASCII lowercase, right? Or, you know, English alphabet, right? So, and it has unique characters and distinct, so there's no duplication. So in general, what do we call them, such a group of things? So there's some mathematics also here, small reference to math as well. So as here the group of item is, you know, in unique characters, right, in English. So we have 26 of them. But in general, if we have something, few things that are unique and distinct and not repeated in the group, what do we call them? We call them a set, right? So that's the definition in math, right? So in a set, we don't have duplicate elements, right? So it's a set of unique and distinct character items. So we call them set. And then, so if it is a set, then there is probably, we might need to you know, check how sets work in Python, right? So it follows along mathematical definition of sets, right? So we encountered set as a type in module 8 and maybe one other occasion as well, but we didn't go over in depth of test operations, but we're gonna kind of use um, and then just fundamental level of things about text to sets today. Okay, But before that, so let's take that. Um, so what I'm going to do is I'm going to, so this is a set, okay. So I'm going to create a set of out of this, okay. So let's print that. So I'm going to print, I'm going to say, yeah, let's say alphabet set. So this is how we create a set in Python, okay. So we're going to pass this whole thing. So set built-in function can create a set. It actually can take any sequence that include a list, a tuple, a range, um, a string, and it actually returns the respective set. Okay, so okay, and then you will see that actually it's so when we print it, right? So it's actually curly bracket. So this is actually a set literal. Okay, so this is the character set in English. Okay, all right. So now let's take a look at the phrase we have. So we're gonna remember this is we are still doing the understanding, right? So we take one of the example given, and then we're gonna kind of see if we can come up with a pattern, right? So oops, and this is gonna be equal to this one. All right. So so this is our phrase. We're gonna basically create a set of this as well. Okay. So so I'm gonna um, phrase set. I would say. So set, and we're gonna pass phrase, right? Okay. All right. So we get a set of that, right? So if we print that, right? So so we get a set. Okay. So yes. Why is it getting randomized every time? Yeah, so that's a good question. Do you know? You actually kind of encountered possible reason. I was going to ask why it was not in alphabetical order, but then I noticed that when you yeah, I think that's the reason. It changed. Yeah, and then it changed again. Yeah. So that's the reason. Set are unordered data structures, right? So there's no idea of index. There's nothing like that. So there is an ordered set actually. It's actually the ordered set. It's what we call frozen set in Python. Frozen set is actually ordered, but regular set in Python it's not ordered. So there's no idea of order or index. So every time it's kind of random thing. So randomly printed. Okay. All right. So the thing is, we can basically, I mean, we should be able to create a set out of this phrase and set out of the alphabet, and we should be able to compare, right? How is it sounds valid thing to do, right? So we get a alphabet set, right? We also get a set from our phrase, which is English, right? And then we should be able to compare, right? I mean, that's should be okay. So then basically we can see that this is actually a pangram, right? So we should, if you compare these two sets, we should return true, and we will see that, right? Print. Okay. Okay. So well, let's do this first. Okay, I'm going to show you, like, remember we covered this truth value testing and also the type comparison, right? So I'm gonna take two list. Okay, so this is just a build up. Okay, so let's take this two list. Okay, and I'm going to compare it to the same again, right? So what if it is again the same list, it should return true, right? So and you will see that it will return true. Okay, so this return true. Okay, so but if I change the order, right? So I'm gonna do this, right? I'm gonna change the order, so 2 here and 1 and then 3. This return false. Okay, all right. So and you can see that because they are list, right? Okay, but if I actually create a set from each, okay, I'm going to say set 1 2 3. So I'm going to pass this whole thing, right? And then I'm going to compare set 2 1 3, right? I get true. Okay, and this is the proof, right? So sets are unordered. Okay, so I get proof. So basically, so you can see that the I might see the same set of, I may not see the same set of characters, but if it's same, well, I should get, then I should be able to compare the two set, and if it is true, well, it's a pangram. Otherwise, it's not. Okay. So there's few problems we still need to resolve. So basically, so what we should do is we should get a set from the phrase, we should get the set from the alphabet, and then compare. And if it compare true, well, the phrase has all the characters in the alphabet, otherwise not. So okay, so but we still need to do some pre-processing. Look what happened when we compare the alphabet set and then the phrase set, right? So print, right? So this and then phrase set, this returns false. Okay. Why? Yes. Yeah, right. So those are the, yeah, so we basically need to strip off the space and also normalize the case, because the problem statement didn't mention anything like, you know, about case dependence or anything, right? So we basically need to normalize the case and also strip off the space. So how do we do that? Yes. Yeah, so there are two functions, right? So that for that you need to go to the Python documentation. One is lower, right? This is I think right here, this function. So basically make the entire string, to, in this case, lowercase, right? And then the other one, there are many options, but you can use replace. Okay, so basically you take the so in this case space, and you replace with something else, or right. So basically, so we can actually do one thing. So we can change the um, the lowercase. So the big, basically I'm going to take it over here, phrase dot lower. Okay, and you will see that now all the characters are in small case, but we still returning false, right, because of the space, right? Right. So so now to strip off the the space from this, so I'm gonna replace. So replace what with what? Replace space with empty, right? You can also put a as well, right? So because A is now duplicated. So when you create a set out of duplicated set of things, you're going to remove actually duplicate elements. Yeah.
If you put A and there's no A in the original phrase.
Oh, that's a good case actually. Yeah, I mean that's really clever. Yeah, you're right. So we will have to actually replace with nothing. Yeah, I take it back. Yeah, good thinking. So yes, that's basically makes our code inconsistent, right? So yeah, so you cannot even put anything else. This is the solution. Basically, it has to be a yeah. Okay, so empty. Okay, now you can see that's actually true now. So it's a pangram. Okay, all right. So these are the things. So basically, we did based on example. Basically, what our function should do, right? So we can now actually write our plan. Okay. I recommend doing one more workout, but you know, for now, in this case, this is sufficient. So input these two. Two, I would say convert the alphabet to a set. Well, um, well, I would say normalize the case, right? No, convert the alphabet to a set. Okay. 3, normalize the case of a phrase to a lowercase, or just one case, right? 4, remove the space from the phrase. Now we're going to create a set out of the phrase, right? The character set. Six, return the comparison, the alphabet set. So I'm going to say this one, alphabet set. This is fine. Phrase set. Alphabet set to the phrase set. Okay. Okay. That's it. Okay. So let's write our code over here. What's a good name?
Is underscore pangram.
Yeah, that's exactly what I thought actually. Is underscore pangram. Because this is a true false returning function, right? So the answer coming from the is. Okay. And then the two inputs, phrase and alphabet. So returns true if the phrase and the phrase is a pangram of the alphabet. Okay. All right. And then you will see that, so we're gonna basically convert the alphabet to a set, right? So so um, alphabet set equals, and then actually we don't need to yeah, we don't need to create that. We can basically use it at the moment, guys. Okay, so we're gonna, in the return statement, we'll do that. Okay, but you can see that number 3, 4 and 5, we can do it all together. So for example, right here in this action, right, so we have number 3 lowercase converting, and number 4 replacing, and then number 5 creating a set. So 3, 4, 5 can be done in a single line of code. Okay, so right, so I would say phrase set equals this, right, set all of this. Okay, and so now basically return, right, return the comparison, right. So if I already have, I can actually yeah, this one, but I actually will do the alphabet set right here. So this is alphabet, so this should be a set. So this is step 2 actually. Okay, all right, so let's call this function. Okay, print for we already have the phrase, but alphabet is, we're gonna submit this one. So it should be coming from this, right? So I think we have it somewhere here. String module. Okay, so instead of this one, you can see that this is a type, so name error, right? So I don't have this defined. So instead of this, I'm gonna submit this. This should return true. Okay, so let's try for another phrase. So I'm gonna say phrase equal, and let's try the last one I have given you, right, which is this one. And you can see that this is not a pangram. Okay, oops, sorry. Why is this not a pangram? What's missing? Z, C is, yeah. Why is missing? Oh, why is there? Z is there. Oh, letter C. Yeah, yeah. What's missing? G is missing. J is missing, right? Yeah. So this is not a pangram. So we'll basically see false. Okay. So it's false. Okay. All right. So that's it, guys. So you can see that, right? See that it's just, I mean, you can even write this solution in a single line of code. Okay. And remember, we did not use loops, right? Because the set function takes care of it. Okay. So this checking for this individual character, whether it's in there or not, taken care of by set. So if you use a loop, this question, let's say, imagine if there's an interview and then you use a loop to do that, and that's basically an indicator for the interviewer that you don't know about sets in the particular whatever the language. So pretty much many modern programming language has the set as a fundamental data structure. Okay, so and then if you don't use that, and then that's a turn off for the interview. Okay, so that's why this is the most optimum solution. Okay, so you can use a loop and check for each character, right? So there are ways to do that as well, but this is the most anticipated solution. Okay, that use the set knowledge. And also it shows you that you know about sets. It's a really important data structures in programming. Okay, all right, so let's answer those 5 questions. Oh, didn't I? Okay, right here. Write a module and an attribute of that module that you use in your code. So it's a string module. So right here, the attribute we used of that module is actually this one. The right here, the ASCII lowercase the attribute. So string and ASCII lowercase the attribute. Write 2 punctuator type tokens you use in your code. Punctuator type tokens. Yeah, colon is 1, right? Colon is 1, and then which sign? Yes, pound sign also 1, right? So this quotation also punctuated as well. Okay, so there are 3 over here. Write an operator type token you use and the respective operands in your code. So what is that? Operator we use. Operator we used. Yeah, so equality operation, right? This one. So in particular to this one, what are the operands? Yeah, this is 1 and this right here, the 2 operands, right? So this is a binary operation, right? So write a formal and as respect to actual parameter, the argument. So this is our function definition. What are the formal parameters? Phrase and alphabet, right? And then you go to the call, that's where you see the arguments. So if you take this one, these are the argument, phrase and then string dot ASCII lowercase. Okay. Those are the actual parameters or the arguments. Write 2 Python reserved words you use in your code. What are reserved words? Set is set a reserved word?
Well, it's the same color as def, so I kind of just.
Yeah, that's misleading, right? Yeah, it's not. It's a built-in function. Built-in functions are not reserved words in Python, right? So unfortunately, this tool tend to mark all Python all things coming from Python in blue. So it's also marked set as set and print. See that print also, right, in blue. But these are not keywords, right? So def and return, they are keywords, right? Okay. Yeah, this tool is in that sense could be misleading. Yeah. All right, that's it. Any question on this problem, guys? So this is a good problem. That's kind of you got to know about sets further, and then how to create a one and then compare sets, right? So and And remember, sets are unordered data structure. So that means in comparison, it doesn't have to be ordered visually, right? So Python takes care of properly comparison. Okay. All right, so let's go to our lesson, guys. It's right here. So we're going to start our lesson on privacy and security. So again, this is a conceptual topic. That's why we're going to kind of go fast. All right. So I mean, there's a kind of metaphor over here. So when someone goes over like a wet floor or something, you're gonna leave footprint, right? So basically, that is to say, the moment you connect your computer to the internet, which means you connect to your home router, like home Wi-Fi, or a coffee shop somewhere, at that moment, basically your privacy, basically, I would say, like, in a way, it's kind of compromised. It's not that lethal, right? But it's still compromised. Why is that? So I'm saying that the moment, so it doesn't have to open the browser and go to internet or something. The moment your Wi-Fi connect to your home network or coffee shop network or CCSF, at that moment your your privacy is now not private anymore. So how do you explain? Yes. Yeah, the IP address gonna get shared with the ISP, internet service provider first. So it's gonna go to the router first, and then IP. Like let's say it's AT&T. AT&T has a big server serving, right? So they're gonna keep a record. Okay, so this computer connected to the router this moment, this time. So that's a line in that big logging text file. And you can imagine now how big this logging file is going to be. Each access request is going to be a single line in the server. So and then we have how many, like, billions of people in the world, right? So and you can see that easily this logging files gonna reach up to, like, the server access logging files into petabyte scale um, thing, right? So scale text files. But they still have to do it because those are the sometimes they are liable, required to, like, by the law they are required to track these for various purposes, like for example law enforcement or legal issues. Those things they should be able to, in case something comes up, inquiry comes up, they should be able to represent, okay, this is the access report of this IP address, this computer, right? So they actually do this log. There are optimization strategies, and one probably obviously once in a while they probably dump this, like delete these files, right? But they still keep them. So that's why I'm saying the moment you connect to a network, your privacy is shared with someone else. Okay, and usually that's okay. It's not that unsafe or anything. But there may be places where it can get compromised, right? So we're going to go over that in this topic. Okay, right? So and you can see that there's a like, the request type. There are post request, there are, like, put request, and then get request, and then each request kind of, it has the timestamp, and then the IP address which is yours, and then other information, like, so usually a single line in that file. These are really big files. Okay, and there are even like, for example, Java has log4j package, like module, that's designed solely for this purpose, like logging internet activity. Okay, And there are other things with like you have when you post a file, like for example, like a let's say you have a JPEG file that you are sending it to Google Photos. There are metadata, right? So Google actually read those metadata, and then sometimes even you know do things that um, for example organizing, right, based on the location, based on the time, based on the occasion, right? So they may even create albums as well. So the reason is they can read the metadata, and based on that they do things. And sometimes okay, for us it's a benefit, but sometimes it's kind of we feel like okay, our privacy is now validated, you know violated, right? So like for example, so there's a frequent location we are coming, our photos are coming, and then basically now there's advertisement from that location popping up, right? So those kind of things we may feel like the privacy has been violated. Okay. Right. So the thing is, that's why I said earlier, right? So the moment you connect to a network, you cannot accept any anonymity. Okay. So I mean, basically, it's your computer, and then the thing is, even though the IP address is dynamic, that dynamic schedule, ISP has it. So they can go to a point of time and go, okay, so this point of time, this was the IP address of this computer. So they have that information. So even though your client's IP address is dynamic, it's already tabulated with the ISP. So they know, and law enforcement can track it down as well if they need to. Okay. All right. So that means you cannot accept 100% anonymity even with the virtual VPN, virtual private network. It's still the case. Why? The VPN service provider has that. They basically shadow your IP address from the rest of the internet, right? So the other people would not know your exact IP address, where you are coming from and things. But the thing is, so they are also doing a mapping, right? So they have your actual IP address tabulated with themselves. So even if your access coming from a VPN, if the law enforcement reach out to them and they are legally bound to release that information. Okay. So I would say you cannot get the 100% anonymity on the internet. Okay. But the thing is, internet is public place, right? So I mean, people, I mean, are allowed to go and access things. So it's not that like it's not prohibited or anything, right? So and that's why we have all of those websites, including porn, out there, right? So people do access them. Okay. All right. So yeah, but the thing is, yeah, so it's kind of a nice, a smart design, but still, people go around it as well, right? So it's designed in a way that um, people cannot do a lot of illegal activity without being caught or anything. So it's kind of designed smart way, but still there are a lot of holes in there as well. It's not perfect. Okay. All right, so there are things, if you want, like things you can do, some strategies with some things, like for example, you can turn off the location recognizing feature in your smartphone. So those things are there, right? So there are things that you can do to improve your privacy. Okay. And then there may be laws as well. Okay. All right. So well, so the the biggest reason is there's a money tag for data, right? Information, right? So a lot of companies and a lot of websites actually sell the access data to other third parties, and then they mine to find patterns, and then it's mainly for advertising purpose, but there are other sinister purposes as well, right? So and if you want a good real good example, you know we many people thought, like, Facebook is a good liberal website and things, right? But in the 2016 election, they actually sold their user data to a third party company, which we call um, yeah, Cambridge Analytica, right? So they did analytics to find the subset who are potential Hillary voters, right? And then use that subset to post negative ads on Hillary, right? Hillary Clinton. And one of those famous advertisement was a game where, because remember Hillary Clinton had an email server thing, right? So there was a email flying, and then you have to shoot down those kind of thing, right? So right. I mean, you can see it. I mean, you found out the subset of potential Hillary voters, and put negative ads, and that's something kind of unfair to her, right? Because it was actually some of those were actually misinformation. And then, to matters things was, she refused to apologize early enough. So, well, you know what happened next, right? So yeah. So the thing is, yeah, those things can be done as well on your information. Okay. So in that case, I think it was billions of dollars Facebook sold that data set to Cambridge Analytica, I think. But you guys can find the information on the internet, actual values. We thought, Facebook is really innocent, nice, and thing, but no, right? So they actually sold their data, right? And without actually consent from the people, right? So they probably have really vague privacy statement behind that, but use that to do that, right? So so that was the moment, actually, to me personally, I became really skeptical about Facebook, and kind of lost the trust in them. I know personally many of my friends deleted their accounts as well, you know, from Facebook. Okay, and then, well, others also, like Google, Twitter, all of those do such things. Okay, so sometimes they're okay. The action is innocent, but sometimes they go beyond their authority as well. Okay, they overstep the regulations they have. Okay. All right, guys, 12 o'clock. Let's get our break. Okay. All right, guys. So since we all of us have here, so let's watch our video today, which is this one. So this is related to this module, and we're gonna actually discuss this topic in a little bit in details. You also have a quiz out of that as well. So this is the one video today, and take a good look. This is really short video, but the guy is actually demonstrating an internet attack. Okay, so so basically the core idea behind this attack is, um, underneath every internet server and things, we have code running, right? So, and then the way we input to our web servers is through the client, the forms we have, right? So we enter, let's say, for example, first name, last name, that's an internet form, right? So let's say you are signing up for a user account. So you have a form, you fill it out and then send it, right? Usually that data, usually it's string, right? But people can submit code via that string as well. So what happens if you do not properly escape that code, right? So we call it's a crafted input. We call it like a crafted input. So now, because these servers run code, right? Now that piece of code goes into the server, and then server may run it. And then that piece of code, if that piece of code is malicious, then the person who send it can do something illegal with the server, right? So that's the idea of this, crafted code attacks. And one example is actually SQL injection. So, SQL injection. So SQL injection means, SQL means coding language, database coding language in particular, that the internet servers use to store data, right? So, and then basically you can submit SQL code as an input to a form, and then your server may run it, because many web servers run a separate database servers as well, so they may run it. Okay, so let's watch this. So I just published it, guys. It's in module 13. Okay. All right. So what he entered was some SQL code that returns the first in the table. So that's not actual username he entered. It's actually a piece of SQL code. So actually, the server took it and ran it on the server, database server, and returned it. So the user could log in without even the password, right? So that's actually the injection. So injection means you inject crafted code, and then now the server runs the code, and then, well, return something, like if it's a malicious attempt, something illegal to this, like for example access to the server. Okay, all right, so let's go back. I think you may have seen this for yourself as well, right? If you have two telephones, like, regular old telephones, at your home, right? If someone, like, can take a phone call, and then someone take the other one and can listen, right? So simply because it's actually something like this, it's connected to another phone, maybe upstairs and downstairs, right? So and then someone can, exact same thing can happen for the internet as well, if, right? So because most of the internet goes through wires, right? So, or optical cables, or it's Wi-Fi, so wireless, right? But if the information is somehow not scrambled, right? Someone can tap in and read it, right? So basically, that can happen. So that's to avoid that, we have this thing called encryption, which basically scramble um, text, plain text, into a ciphertext, which is hard to read, right? And then only the two people who in the conversation knows how to unscramble and scramble, right? So that's the idea of encryption. Okay, so there are various techniques of encryption, right? So one usage in this animation, you can see that. Let's play this one, right? So basically the thing is, the user is paying the electricity bill through the electricity bill company website. So this is the client, your browser, and you are paying, right? And it has that request carry the credit card details and everything, right? So it has to go to the electric company server, right? And it has to travel through this network. So if you do not encrypt it, then people can illegally access that information and get access to those credit cards and whatnot, right? So let's play this one. So this is the information we are sending out, and you can see that it's actually plain text, right? But when we encrypt, so right at the browser, right, the moment we click the pay button, right, before even goes to the internet, that client page, which is the browser tab of the electric company, encrypt that into something like this scramble, right? So no one can read and um, get information from that, because the way only electric company only the way knows the way to unscramble it, right? So the information is safe. Okay. So and then basically company receives the scrambled text. It only knows how to unscramble it. It can unscramble and then get the payment information. Okay. So that's the idea of encryption. There are several techniques on doing that, right? For several ways of communication, and this is for Wi-Fi. So we have WPA2, WPA, and then WEP. I think this is the most the current one, right? WEP. Yeah. These other there, I think there are versions as well. Okay. So right, and then for emails we have PGP, pretty good privacy, and then the SSL, which is the secure socket layer. Okay. SSL. And then for the web, we have HTTPS, Hypertext Transfer Protocol Secure. For example, our Cybook page, right? If you click on over here, right, you can see that HTTPS here, right? So that means this your communication between the Cybook server and then things you submit gets scrambled and encrypted and sent over. Okay. So and then for files transfer, we have files transfer protocol FTP, which is not a secure one, and to make it secure, we have SFTP, secure file transfer protocol. Okay. So the usual way this security this scrambling works is you basically use a cryptographic key to encrypt, and then to decrypt we need that key. So if we can keep the key secret, then basically the information is uh, secure. Okay. There are some examples as well, guys. And these are again there are like things that you can read and understand. um, these are all again conceptual topics, so I'm going to quickly run over them. So things that you can do to protect your privacy as well. Okay. And this also, like, I'm going to skip this one as well, guys. I think, yeah. Some case studies are there. Okay. So let me take a moment to, so this is our, the week before last week, guys, right? So semester ends on 20th, but the last week is for final exam week, which we don't have classroom discussions. So basically, so let me show you. So right here, this is coming from this website, guys. You can Google CCSF calendar, something like that. It will come up this one, and if you click on spring, you'll get this one, right? So you can see that. So this is this week, right? And this is next week. Our last day of instruction will be 12th. That's our last day. Okay. And then 13th, starting 13th, we begin the final exam week. So it's 1 week. Okay. So our you guys should know that our final exam is paper based, in person here, right? So right. So we're gonna have a so let's check when will be our final exam. Okay. So it's actually here. So you can actually go over here, click on this and figure that out as well. Spring final exam schedule. Okay. So that is this one. Okay. All right. So here's how you read this table. Okay. So this column is class start time, and then we have few columns. Our class is Tuesday, Thursday, which is this column. our class start time is 9 to between 9 and 9:55. So this is the row for relevant to us. So we go all the way to this column. So our final exam will be on May 19th. Oh no, not this one. So this class start at 11, right? So I was referring to previous class. This class starts at 11:55, right? This is the row. Our final exam will start at 10:30 here. Okay? This class, this room. Okay. So 10:30, 12:30 p.m. right here. So do not show up at 11. You'll be late. Okay. You have to come at 10:30 for the final exam, which is on the Tuesday week after next week. Okay. So including today, we still have 3 days of instruction. So today, Thursday, and next week Tuesday. Okay. So we can finish. The last module is module 14, which is this one. Okay. So which is the AI and computing. That's one. So pretty much these 3 modules we are taking like one day and a half to finish the module. Okay. So so I wanted to go over that. So remember again, so we will have, so this Thursday, this is not a class lesson. So we are preparing for the exam, which is the practice exam. We're going to have regular class hours right here. We will have our paper-based practice exam. So I will print the exam paper and you will come here and take it. So it's your practice exam. Okay. So, and then you will have extra credit for that. Okay. So don't miss Thursday 14th May class, guys. Okay, please. We'll do our practice exam on you. Okay. All right. So let's go back to our lesson. All right. So there are some recommendation on how to share your information, when to and how to, right? So so again, a lot of information on like on data as well, and then some strategies to minimize negative consequences of online behavior, right? So for this class, you guys should know what there's one, right? There's a for this. I mean, this is a hybrid class, right? So content is available online as well. So and you guys interact through the discussions with others, right? So remember the net equity thing, right? So if you take I think every discussion has that, right? So for example, if you take this one, I think I have that advice, right? So FAQ page should have the like that, you know, follow netiquette on the internet. Okay, so that's that one, something similar, right? So that's it's actually talking about something that one. Okay, all right. So there are some case studies. Facebook recognition system, face recognition system, and biometric data privacy. There are some lawsuits, right? Remember, right? So I think New Mexico State, right? Do you guys remember? They actually recently passed a law on, right? I think on minors, right? Access to social media. There was, I mean, New Mexico State passed new laws. Australia recently, remember, right? They kind of prohibited social media access to anyone below 16, I think, right? So the reason is, you know, it's it's really right now the social media access for teenagers is negative. Basically, a lot of negative things happen. There's bullying, and there's peer pressure happening through, and then even there were suicides happen through that, right? So they wanted to avoid that. Okay, those things. Um, the thing is, this sometimes this.
That's going to entirely solve these problems, though. Just my personal opinion.
What is it?
I don't feel like banning things would solve all these problems. It's like reminds me of prohibition, where you ban alcohol.
Oh yeah, yeah, you're right.
Does
But
it really like stop Elden Ring? No. Just creates more
yeah,
crime.
but the thing is, there has to have some control, right? I mean, if you don't have proper laws, and the thing is, there's always this bad guy going to abuse the system, right? So it's not exactly similar to prohibition. Like prohibition is something related to freedom as well. So they were entirely trying to prohibit that, right? And you cannot stop that, right? People are going to illegally do things when you prohibit everything, right? So this is basically harassing someone on the internet. It's something you should not do, right? So yeah. So but yeah, it's there's some similarities to prohibition as well, some of these laws. But safeguarding teenagers, something good, right? So I mean, we should have laws on that. But yeah, you're right. So it's too much of it going to you know be a problem, because it's gonna um, violate the freedom, right? So of the freedom of information, all those things, right? Sorry. All right, so we're gonna start the next Tuesday with security basics, guys. Okay, so I'm going to open the problem today, which is this one, the password generator. Okay, I have it probably. So this is more common. So you may have seen like some website. Oops, what happened? Oh, I think I know what happened. I need to refresh this page. I deleted the old version, that's why. Did I import it? Okay, I need to actually import. Give me 1 minute, guys. Need to import it from the other class. I think it's not showing up. So this one. Oh, it's there. Okay. Why it's not coming up then? Yeah, I need to refresh one more time. Oh, I think it's here. Yeah, there you go. Okay. So all right, I just published it, guys. It's random password generator. So this is a common problem. It's common thing that we see, right? When sometimes when you create new user accounts or things, and then browser or the website offer you to create a random password, right? So there's a bunch of criterias, and then basically you have to, based on this criteria, you should write code to create random password. That's it. Okay, that's this problem. Strong passwords